Waste number 5, waste caused by not using boiler water treatment chemicals. This is a mistake I see very frequently in factories. Many people think that if we don't use water treatment chemicals, we can save money every month. Some people even feel that using water treatment chemicals makes no noticeable difference compared to not using them at all. This may sound reasonable, but in reality, the opposite is true. When boiler feed water is not properly treated, dissolved chemicals will precipitate and adhere to the surfaces of the steam-generating tubes, forming scale. This scale acts like an insulating layer covering the boiler's heat transfer surfaces. As a result, heat from the combustion chamber cannot transfer efficiently into the water, forcing the boiler to consume more fuel to generate the same amount of steam. Scale not only increases fuel consumption, but can also cause localized overheating on the boiler tubes. When heat cannot transfer into the water properly, the tube wall temperature rises excessively, causing tube swelling, cracking, or even tube failure. In addition, untreated water can cause metal corrosion due to unstable pH conditions. If this continues over time, the boiler's lifespan will decrease significantly. So the money that appears to be saved by not using water treatment chemicals can actually cost a factory much more through higher fuel consumption, higher equipment repair costs, and a significantly shorter boiler lifespan. The hidden costs caused by not using water treatment chemicals are often many times greater than the cost of the chemicals themselves. And once again, I strongly recommend using proper water treatment chemicals for your boiler system. If you operate in the food industry, use food-grade water treatment chemicals. If you are in the pharmaceutical industry, use chemicals that meet pharmaceutical standards. Waste number 6, waste caused by boiler design and operation not matching actual steam demand. This is a very common type of waste in many factories. When designing a steam system, many factories tend to select a boiler with a capacity much larger than actual demand, or add a large safety margin in case the boiler performance decreases over time. This may sound reasonable, but in reality, this creates a contradiction. The boiler is designed for a large capacity, but once the factory reaches a stable operation, the actual steam consumption is often much lower than the original design value. As a result, the boiler operates under low-load conditions for long periods of time. Technically, most industrial boilers achieve their best efficiency when operating close to their design capacity. When operating at very low load, combustion becomes less efficient, combustion conditions fluctuate more frequently, and fuel consumption per ton of steam increases. You can think of it like a car. A car is most fuel efficient when running at a stable speed. But in the city traffic, where the driver constantly accelerates, brakes, and slows down, fuel consumption increases significantly. A boiler works in the same way. If a boiler is designed for high capacity but continuously operates at low load, it is like a car constantly running in low gear. When combustion conditions fluctuate continuously, combustion efficiency drops and fuel consumption rises. A very effective solution in this case is, after the factory has operated stably for some time, the actual steam demand of the entire system should be remeasured. Adjust the fuel feeding system. Adjust the combustion air supply. Optimize combustion conditions. In some cases, it may even be necessary to optimize the furnace configuration to better match the factory's actual operating load. When the combustion system is optimized for the actual steam load, the boiler operates more stably and steam production costs can be reduced significantly. Waste number 7, waste caused by wet steam. Another type of waste that many factories overlook is wet steam in the steam system. In principle, steam supplied to production equipment should be dry saturated steam. However, in many factories, the steam reaching the equipment contains a significant amount of tiny water droplets mixed within the steam flow. This usually happens when the moisture separation system is ineffective. Steam traps installed at condensate removal points do not operate properly. The steam piping system is not designed correctly and lacks steam separators, or the steam velocity is too high, carrying water along the pipeline. When steam becomes wet, heat transfer efficiency drops significantly. Wet steam not only wastes energy, but can also cause problems such as water hammer in steam pipelines, damage to control valves and pressure reducing valves, and reduced lifespan of many steam system components. Therefore, in steam systems with long pipelines or sensitive steam-consuming equipment, installing steam separators before critical equipment groups is a very effective solution. Steam separators remove water droplets from the steam flow, ensuring that the steam supplied to equipment remains dry and stable, improving system efficiency and significantly reducing energy costs. Waste number 8. Waste caused by not using a deaerator. In practice, I often hear a common opinion. A deaerator is basically just a water tank. It's cheaper to use a normal water tank, and deaeration doesn't really make much difference. Some people even say, a deaerator also requires steam for heating, so it wastes additional energy. This may sound reasonable, but in reality, this opinion is not entirely wrong, yet it is not entirely correct either. First, energy waste caused by steam loss from open tanks. The most obvious issue is steam escaping into the atmosphere. When using a conventional open water tank, returning condensate carries a large amount of heat energy. As the water temperature rises, steam begins to evaporate and escape into the air. In many systems, once the water temperature reaches around 80 to 85 degrees Celsius, visible steam loss becomes significant. If the temperature increases further, steam loss becomes even greater. This is energy the factory has already paid for by burning fuel, yet it is lost before returning to the boiler. A deaerator, on the other hand, is a closed vessel. It can heat condensate to a much higher temperature without releasing steam into the atmosphere. Even visually, the difference is very clear. Open tank to large amounts of steam escaping deaerator to almost no visible steam loss. This is a major hidden energy loss that many factories fail to recognize. Besides energy loss, there is another more serious but less visible problem: internal corrosion. Boiler feed water always contains dissolved gases such as oxygen and carbon dioxide. Oxygen causes metal oxidation. Carbon dioxide dissolved in water can create a mildly acidic environment, accelerating corrosion. This is a hidden form of waste, but when failure occurs, the repair cost can be extremely high. A properly designed and operated deaerator removes most of these dissolved gases before the water enters the boiler. Third, operational instability caused by unstable feed water conditions. This is another issue many factories experience without realizing it. When the boiler is operating, unstable feed water temperature can cause pressure drops, temporary steam shortages, and disruptions to production. When using a normal water tank, water temperature may be low or unstable, and every feed water cycle cools down the boiler system. In contrast, when using a deaerator, the feed water is already preheated and stable, so it causes minimal disturbance inside the boiler. Boiler pressure becomes more stable, steam generation becomes smoother, and the system operates more efficiently. This difference becomes even more noticeable when the boiler operates at low load or under fluctuating steam demand. From the outside, a deaerator may look like just another water tank. But technically, it is a critical piece of equipment that helps reduce energy losses, minimize corrosion, and stabilize boiler operation. Therefore, not using a deaerator or using it incorrectly is not a cost-saving solution. It is actually a waste of energy, equipment lifespan, and overall system operating efficiency. We have just gone through 8 hidden boiler energy losses commonly found in factories. In boiler systems, burning more fuel does not necessarily mean producing more steam. Instead, the factory that controls energy losses more effectively will achieve lower operating costs. And in today's market, that is a real competitive advantage. I hope this video has been useful for you. If you have any additional ideas or suggestions, please leave them in the comments below. Thank you very much.